So I'm going to say something which is kind of counter probably to what Ira is going to say, which is I'm also getting to realize that there's been so much good research in machine learning over the last few years that I think if nothing happened for the next 5 years, we're still in good shape, because there's so much low-hanging fruit in companies. Companies are still struggling with the basics. So there's a lot of opportunities just productizing and building solutions, just like what Anodot is trying to do in many of these existing machine learning algorithms. And in fact, I think even the AI communities that I follow are realizing this. So, you read a lot about the hype around AI, but investors are definitely focused on funding companies that are building kind of narrow and focused solutions. So that's kind of in general. So me in particular, what I'm interested in is somewhat similar to what Anodot is working on, which is, I would say, I'll make this distinction between streaming and live data. So it turns out in AI, you always have the scenario where you have an agent or a user interacting with an environment. So currently people are talking a lot these days around reinforcement learning, which basically you're trying to learn some policy, given an environment, what action should I take? So you're trying to learn this policy. So it turns out that our existing tools are not well suited for this problem. So the kinds of tools built based around MapReduce, for example, or Spark. So there's a lot of excitement around this. If you kind of list what kind of features should such a framework have in order to support interacting with live data, it turns out this framework doesn't exist. But people, for example, the people behind Apache Spark are about to release a framework called Ray, and it's designed to do machine learning against live data. R-A-Y, yeah. It's actually, I just got a, what?
Which people?
AmpLab, now Rice Lab.
Rice Lab?
Yeah. I just got an email from Elon that it's out. But the nice thing about Ray is it's actually the problem they're tackling is a lot more generic than reinforcement learning. It's this whole machine learning in dynamic environments. So, for example, they are able to easily replicate some of the things that OpenAI did around neuroevolution algorithms as an alternative to reinforcement learning. But I've kind of just come to the realization actually that for a long time I thought about real time as streaming. Because that's the world I occupy at Strata. But to be honest, there's a lot of real time that's not necessarily streaming. It's just this episodic interaction with live data. And I think as these techniques become more accessible, maybe even next year we'll see data scientists using these frameworks to tackle this type of machine learning problem. So,
what's the biggest challenges you see for machine learning in the next few years?
I think training data is still a big problem. So for example, deep learning, at this point, deep learning still requires a lot of training data. So if you look at where deep learning has made huge progress, it's usually in these areas where you have large labeled training data. So people are trying to innovate around algorithms that require less training data, but that's a work in progress.
I have a question for Darmis that many ask. The difference between AI and machine learning.
So to me, machine learning is a component of AI. So to me, AI will have machine learning being usually the pattern recognition or perception layer of AI, but an AI system will have probably access to some sort of knowledge base, some sort of reasoning and planning capability, and then the ability to use different forms of machine learning like reinforcement learning and things like this. But so that's a big question. that Cloudera asked me because we organize an AI conference separate from Strata.
Strata is Cloudera.
Yeah. So,
Any questions? Anybody planning to be?
so by the way, AI is a huge topic in Asia. I mean,
Asia?
Yeah, because I organize a conference in Singapore and China. Huge topic. That's all they want to. Every time they ask me, that's the only content they care about this year.
Yeah.
I heard that AI is regarding only human interaction stuff, that you try to imitate the human via machine learning, which is more for things that are not, for example, Anodot is not AI, it's more maybe machine learning.
Machine learning, yeah. So I think, so right now, obviously deep learning is the main technique that people use, so, but arguably it has kind of characteristics of neuromorphic computing, but it's not exactly how the brain works. So there are people who are trying to take deep learning and infuse it with characteristics with how the brain works. So Josh Tannenbaum at MIT, for example, is doing great work in this area. But I mean, like I said, deep learning as a technique, data scientists are using it as a machine learning technique. Right? So we're seeing more and more of that. Oh, so the other thing that's starting to emerge in the Bay Area, at least, is this new job title, which is a hybrid. You've got the data scientist and the data engineer. So people are now coalescing around a new job title called the machine learning engineer, which is basically a data scientist with much more production and product focus. So whereas a data scientist might be working in R and Python notebooks, the machine learning engineer is able to touch production systems. So they have stronger software engineering skills. They know how to use Git, for example.
It's a machine learning that is not only in theory.
Yeah, and then they also think more holistically, like, so what's our logging infrastructure? If we have an A/B testing infrastructure, what is it? And then they care about things once it gets deployed in production, right? So how do we know a model is stale? And things like that. So that's starting to emerge in the Bay Area. People are starting to use this term in job postings, and in particular, the companies that have bet big on deep learning have a specific title called deep learning engineer. And so, yeah, so usually the machine learning engineer may have much more of an engineering background, and then they get taught enough machine learning to not be too dangerous.
Can you share maybe some of the best examples you can think of deep learning being used as a machine learning technique outside of kind of like image classification and audio, which seems to be the most common examples?
Yeah,
that
so
I see.
the two things that jump out right away are recommenders.
Okay.
So, for example, they take the embeddings, right, so the features from deep learning, and then search rankings. And then some people are starting to use some of these recurrent neural networks to model customer paths, right? So you guys may actually start thinking about this. So I know a couple of big e-commerce companies doing this. But I would say recommenders is the default.
So taking the features from the deep learner and using them in a
feeding
recommending
it into
system.
something else.
Yeah.
And then to some extent, people are looking at it for text, but mostly for NLP, the word embeddings and things like this.
It's very relevant to attention.
Yeah. And some time series, although there's a lot of hype there. I was telling Ira, I tasked someone to investigate how deep learning is being used in quantitative finance. I introduced this person, one of our editors, to so many people I know in finance. And then our conclusion is it's all hype at this point. Or maybe the people who are actually using it don't want to talk about it. So, but time series, I think, is going to be an emerging field for deep learning too. Right? So you guys are already looking at it. But next year, live data. That's the bet I'm making. Live person.
My person might be.
Are you building chatbots in that person?
No, we are actually